This is the Unit 3 End of Unit Assessment Test Corrections video. So we're going to be using a calculator, and you can use whichever calculator you'd like. And the first question, a circle has a radius of 50 centimeters. Which of these are closest to its area? So if I know the radius is 50, and I know the area formula is area equals pi r squared, and I'm going to use 3.14 for pi, so area is equal to 3.14 times my radius 50 squared. So this means 50 times 50 times 3 1400ths is my area. So I can go ahead and put this in my calculator. 3 1400ths times 50, and I can use this button right here to make it 50 squared, equals. It is 7,850. So square centimeters. So if I look at this, no, maybe, definitely not, so this is it. Right? And the difference would be maybe they used the pi button when they figured this one out. All right, second question. Select all, so that tells me there might be more than one answer, the expressions that correctly calculate the perimeter of the shape. So I see that this figure has some rounded bits, so perimeter is my circumference. So circumference equals pi times d, or circumference equals 2 pi r. So if I look at this, I see that this side is 10, which means that this side is 10, which means that this side is 10, which means that this side is 10. So for my straight bits, it's just going to be 10, 10, 10, and 10. So 10 plus 10 plus 10 plus 10, that might also be 40. So I'm going to look for a 40. So I've got a 40 here. I've got an 80 here, so that's a no. A 120, no. A 300, no. And then here I've got 10, 10, 10, and 10, so a maybe. All right, so let's do the rounded bits. So this distance here is 10, which means that this distance is 10, which means that this distance is 10. So the diameter of my circle is 20. So, and I've got half a circle here and a half a circle here. So I know that the diameter is 20, so 2 halves make a whole. So I have a whole circle whose diameter is 20, so that would be 20 pi for the rounded bit. Oh, here it is, 40 plus 20 pi, so that one definitely works. All right, down here I've got 10 pi and 10 pi. So what this one must be is that they did circumference equals 20 pi, but this is a half a circle, so they divided by 2, so the circumference of this circle is 10 pi, and the circumference of this circle is 10 pi, so this is also an answer choice. All right, page 2. On page 2, once again, you're being asked to choose all of the true statements. So it says pi is the area of a circle with a radius of 1. So I'm going to write my formulas. Area equals pi r squared. Circumference equals either 2 pi r or circumference equals pi times d. All right, so pi is the area of a circle with a radius of 1. So if I put a 1 here, 1 squared is 1 times 3.14. Oh, yep, so that one works. Next one, pi is the area of a circle with the diameter of 1. So if the diameter is 1, and I know that a radius is equal to half of a diameter, so the diameter is 1, so the radius must be 0.5, which is a half, so a half squared is 25 hundredths times pi. That's not the right answer, so that one's out. Next one, pi is the circumference of a circle with a radius of 1. So if I have a radius of 1, and I put this here, 1 times 2 is 2, times 3.14 is 6.28. That is not pi. So that one does not work. Pi is the circumference of a circle with a diameter of 1. So if the diameter is 1, 1 times pi is once again going to give me that answer. So that one works. Pi is the constant of proportionality relating the diameter of a circle to its circumference. So if I divide this and this, yep, the circumference and diameter, that gives me pi. And then the last one, F says pi is the constant of proportionality relating the radius of a circle to its area. So if I'm doing the radius to the area, so if I say the radius is 2, 2 squared is 4 times 3.14, no, that does not work. So that one is out. All right, the next question. A class measured the radius and circumference of various circular objects. The results are plotted on the graph. Does there appear to be a proportional relationship between the radius and circumference of the circle? Explain or show your reasoning. So when I see a graph, I know that I want my line, my points on my graph to be a straight line passing through the origin to indicate proportionality. And this is pretty darn close. So I would say yes. A line drawn passes through most points and the origin. Now, that's one way to think about it. Another way to think about it is to make a ratio table or a T-chart. So if this is my X and this is my Y, I have 7 and 44, I have 6 and 38, I have 4 and 25, I have 3 and 18, and the constant of proportionality, K, is Y divided by X. So I take my calculator and I do 44 divided by 7, and that is 6.29. And then I do 38 divided by 6, and that is 6.33. And then I do 25 divided by 4, and that is 6.25. And I know that 18 divided by 3 is 6. So all of these are around what I would expect, and because it was a class that did it, I see that they have a similar constant of proportionality, or K. And that's because it was based on class measurements. So you remember when we did ours, it did not work out to be exactly the same. Why might they not be exactly proportional? Human error in measuring. All right, next page. Whoops, upside down. All right, here we go. For each quantity, decide whether the circumference of the area would be needed to calculate, explain, or show your reasoning. So, the distance around a circular track. So that is circumference. And I know it's circumference because it is around the track. Okay, the next one. The total number of equally sized tiles on a circular floor. So that is area, because it's covering the floor. There they are. All right. The amount of oil it takes to cover the bottom of a frying pan. Once again, area, because we are covering the pan. The distance your car will go with one turn of the wheels. So that is circumference. If here's my wheel, it's going around. So it is around. Okay? And the last page, the big page. The, oh my goodness, how many points page. Here we go. Okay. so it says, this figure is made of part of a square and part of a circle. What is the perimeter of this figure to the nearest unit? So if I look at this, perimeter is going to be, because of this rounded bit, circumference. And I know that circumference is either 2 pi r or pi times d. So if I'm finding the perimeter, I'm going to do the perimeter. So 5 plus 10 plus 5 plus 10. So that's 30 for the straightaways. And then I need this area here. So if I look at this, this is 1/4 of a circle, because if I continued this around-ish, right, it would look something like that. So that's 1/4 of a circle. So I need to find the circumference of this circle and then divide it by 4. So I have r, which is 5. So I'm going to use this formula here. So I'm going to say 2 times 3.14 times 5. But when I get that answer, I'm going to divide it by 4 because this is 1/4 of a circle. So 2 times 3.14 times 5. So the circumference of the whole circle is 31 4/10 divided by 4 gives me 7 85/100. So if I add that together, I know that the straight part is 30, the rounded part is 7 85/100, so that's 37 85/100, but I need to round it to the nearest unit, which is going to be about 38 units, whatever it was. Okay? All right, nearest unit means nearest whole number. All right, next one. What is the area of this figure to the nearest square unit? So I need to write my area formula because of that rounded bit. So I know that area equals pi r squared. And here we go. So the area, the way I saw this was I saw the top of this as a rectangle whose dimensions are 10 by 5. So that's 50. And the bottom down here I saw this square. So that's 5 times 5, which is 25. So I have 50 plus 25. And then I've got this area of the circle. So pi r squared. So 3.14 times 5 to the second power equals 78.5. But then I have to divide that by 4 because this is 1/4 of a circle. Gives me 19.625, and then I add that with the 75 I already had, which gives me 94.625, but rounding to the nearest unit is going to be 95 square units. All right, last question. A groundskeeper needs to cover a circular field that is 290 feet in diameter. All right, so he wants to cover the field, so I need to find the area of it. So I need to find out how long this radius is. So to do that, I know that the radius and the diameter, I have to divide by 2. So that's 145. So the area of this field, area equals pi r squared, area equals 3.14 times 145 squared. So I'm going to square this. Where's my square? Here it is. Square that. So the 145 squared times 3.14. And that gives me 66,018 and half a square foot. So that's the area of the field. Then I see that the store sells 50-pound bags of seed and 1 pound covers 400 square feet. So 1 pound covers 400 square feet. So 50 pounds, I need to multiply by 50, covers 20,000 square feet. Because 50 times 400 is 20,000. So this is how much 1 bag will cover. This is how much I need to cover. So I need to divide this by 20,000. And when I divide that by 20,000, so I've got 66,018 and 5/10 divided by 20,000, and that gives me 3.300925, but it's bags of seed. They won't sell me this. So I have to add one more to it. So I'm going to be buying 4 bags of seed. Thank you for your attention.